All right,
Okay.
so yeah, we'll dive on into this. My name is Peter Corliss. I am the Director of Product Marketing at StarTree. Coming up about 1 year I've been here. Before that, I've been elsewhere around the database industry. And so for me, this whole last year has been a tremendous amount of learning. Finding out, like, I'm familiar more with, like, let's say NoSQL OLTP type databases. And so for me, I've spent this last year just discovering all the different stuff that goes into an OLAP database like an Apache Pinot. And so part of this is just me having documented my own learning process. But I found it fascinating, and I hope you do so as well. I'm joined today by Gonzalo. Gonzalo, would you like to introduce yourself and what you do here at StarTree?
Yeah, hi. I'm Gonzalo. I've been working in StarTree for almost 2 years, and yeah, maybe 2 years ago. And I'm mostly working on the uh, open source part of our product, which is Apache Pinot. And and yeah, I recently been nominated as a committer, so that's great. And I've been mostly working on around indexes and performance improvements on the core of the engine.
And so I have to admit that Gonzalo was my guide to a lot of these kinds of things. And if I say anything wrong, it's totally on me. But Gonzalo is here to make sure that I stay on the straight and narrow. And also, he has some great insights in depth as to how users are using this technology and and the hows and whys of the implementation. So I'll be relying upon him for more of the technical stuff. But I just want to introduce you to these topics and again share the kinds of stuff that I've learned because I've been from other companies where a lot of stuff was just all written in house, right? And this company has really changed my viewpoint on how you can build open source on open source as opposed to reinventing the wheel. There's so many different components, and let's get into these. In fact, first though, let's just spend a little bit of time talking about what is Apache Pinot. We may have some new folks in the audience who haven't been familiar with it. They might have seen the fact that we're advertising maybe Apache Lucene, or maybe they saw the Calcite in some of our social media posts. And so they're familiar with those open source projects, but maybe not Apache Pinot. So we'll just talk about it for a brief amount of time. So, and of course, I beg forgiveness of all those people out there that are using Apache Pinot in production, and all of this you've probably seen in 1,000 different webinars up front. Um, so Apache Pinot was invented to solve for real-time analytics. Now, there were many other databases that did real-time analytics, but for what was called user-facing applications, and that meant to be able to do queries at scale. So a lot of real-time analytics systems work until maybe you get beyond a single embedded device. There are some OLAP that you can put in a phone, for instance. But now let's talk about terabytes to petabyte workloads. So you have scale issues. The other thing that you have for real-time analytics is maybe you need to do not just 100 queries per second, but maybe 1,000, maybe 10,000. There are people out there running 100,000 queries per second. So when we talk user-facing applications, we talk about this capacity to meet very large workloads and while still keeping very low latencies. So it's a throughput latency combination there. Uh, the other thing that a Pinot does very well is fast aggregations with multiple index types. So it's a very flexible system to get data out to do your analytics in multiple different myriad ways. It had its origins at LinkedIn. It was invented specifically because LinkedIn had looked at some alternatives and said, none of these are meeting this kind of scale that we need here. And so, like, LinkedIn started using it when it was about, I guess, maybe 100 million LinkedIn users, and now there's, nearly a billion LinkedIn accounts that are out there. And of course, it's since it began at LinkedIn, they open sourced it initially, and then they took it through the entire Apache Software Foundation process from incubation to top level project. You can check out the repo, you can check out the docs. And so there are other meetups we've done that go into what Apache Pinot is, but I just wanted a table set there. We're not going to spend too much more time other than to go through some of the architecture issues, because when we talk about the open source that is in Apache Pinot, you'll find that some of this is running in the controller, or maybe some of this is running in a broker or on the servers, and maybe some of these are being leveraged by the minion architecture. And again, there are other meetups that we've done, other wonderful videos. There's a whole Apache Pinot 101 series that has recently come out that go into the details of each of these and how they work. We could spend an hour just talking about that. But again, I just wanted to give you a kind of a map of what the architecture looks like for people who may not have been familiar with that before coming into today's session. So that's it for the background then. Now let's get into the different open source projects that we'll be talking about that are part and parcel of Apache Pinot. They come with every single Apache Pinot cluster that's running out there. So these are the projects we'll be talking about today. Apache Helix, Apache Zookeeper. Those are both used on the controllers. Then we have Lucine for text-based indexing. Calcite is a basic SQL engine. It's at the heart of a lot of what we do, especially in the multi-stage query engine that we have today, which allows you to do query time joins. Apache Groovy is a scripting package for UDFs. And so obviously other people do that with WebAssembly, or they might be doing it with Lua, right? But we decided to use Apache Groovy, and we'll get into the whys of that. Netti is an asynchronous I/O, network I/O framework, and then Roaring Bitmap. So with that, let's get into each of these components, and we'll talk about them more in depth. We'll start with Zookeeper. It is a well-known and often not well-loved project in the open source world. It is used for consensus across distributed systems. So for instance, other kinds of things that would be like this would be maybe a Paxos algorithm or Raft, but this is the way consensus is managed in Apache Pinot. It is what is formally described as a distributed coordination service. I think that the Paxos and Raft implementations are talking much more strictly about consensus. It is a metadata store, right? So beyond just the cluster topology, it's also storing table configs, schema, cluster state. A lot of metadata is also stored in Zookeeper. It is a venerable project in the open source world, coming out of the Apache Hadoop infrastructure. But you'll see that these days there are a lot of other projects in the open source world, like Kafka and Pulsar, who have been moving away from Zookeeper because of some of its particular bugbears. But we decided to do something else with it rather than just jettison entirely. Let's talk about the next project here, which is Apache Helix. Again, also part of our administrative infrastructure. This is the cluster management framework that runs in tandem with Zookeeper, and in a way kind of hides some of the ugly bits of Zookeeper. Is the nicest way I can put that. And it's what basically divides these different clusters or nodes in the cluster into the different roles that they serve, whether they are servers or brokers or the controllers, minions, etc. So Helix is using Zookeeper as its state metadata store. And by no small chance, it's part of Apache Pinot because Apache Pinot's founder, Kishore from LinkedIn, was using it. In fact, I believe it was for Samza and other projects, even before Pinot was invented. And so he saw it as a natural thing that he wanted to use when he was first working and with the other people that were initially working on Pinot. It was a natural thing that they knew already about. They had invented it, and so they put it into the Pinot architecture from the get-go. So you can learn. Go ahead.
I think it was natural for the team to use Helix here, because Helix is super easy to create this kind of clusters where the nodes talk to each other and send messages and get notifications when there are changes and stuff. So it's quite easier to use than, as you say, than Zookeeper. Also, we still have the cost of Zookeeper there. You have to have Zookeeper running, and usually that's not something people like to do. But yeah, for us it's super great because we are not. I mean, another problem that Zookeeper have is that it may have some issues when you try in Kafka, for example, when you try to create hundreds of thousands of partitions. But then that's not our case. So in our case, Zookeeper is nice, and we don't have usually problems with that in production. So right now we are very happy with Zookeeper plus Helix.
Yes, exactly. So the combination works in tandem then on the controller side. Let's see. The next thing we're going to do is let's go towards the servers and let's take a look at Apache Lucene. You can write your own text-based indexing mechanism. And in fact, there is a native text indexing in Apache Pinot today, but we still have the Lucene index that is in there. It runs as a sidecar next to the Pinot segments. It is far more expressive than the native text index. So even though the native text index may provide better performance, it may use a lot less disk. Again, a lot of people really, when they're doing text search, they want that expressiveness in the search indexing and in the search querying. And of course, there's a lot of people out there that know how to use Lucene. For folks who know Hadoop, they might also know that Doug Cutting cut his teeth on writing a number of different text-based indexing mechanisms. So Lucene is also his work. And so it is, I think, one of the oldest open source projects that are being used in Apache Pinot coming out of 1999. So if any, I mean, there's tons to talk about with Lucene, but know that we have Lucene was what we initially implemented, and now there's this native text indexing, and you have your choices whether you're optimizing for performance or you're optimizing for expressiveness. Is there anything else you'd want us to add on top of that, Gonzalo?
No, I think it's fine.
All right, great. Let's see. Now, this is another one I found out about. And again, I'm coming from my own personal experiences, a lot of NoSQL databases. And so I'm like, what is this? Right? So here's this wonderful engine, Apache Calcite, that's being used across a ton of different open source projects. I've just listed a few of them, like Apache Beam, Apache Drill, Apache Flink, Apache Druid. They're like all of these systems are using the same SQL engine because the last thing the world needs is yet another implementation of SQL. And yet we do see all these different open source projects coming out. There's certainly no dearth of like Postgres, alternatives that are coming out these days. But again, when we see Calcite being used, what's really cool about Calcite is that it's even aware of these different kind of engines. It has MySQL dialect support. It's got Postgres support. We've been adding more Postgres support into the implementation that we have for Apache Pinot. So, again, a lot of what we did, there's whole blogs that have been written about the multi-stage query engine that came out, again, kind of reach this readiness stage with Apache Pinot 1.0. And in that, Calcite's very important for this multi-stage querying that you're doing. So again, that's a whole other meetup that we could do is just, and in fact, there's plenty of great recorded stuff on that multi-stage query engine, but Calcite was critical to that implementation.
Yeah.
Gonzalo, what would you want to say about this?
Yeah, I would say that without Calcite, we wouldn't be able to have this multi-stage engine in so short amount of time as we did, because it's amazing all the features it provides for free, and all the configurations you can change and tune and stuff. Right now, for example, I'm going deeper into Calcite to do some improvements in V2 and fix some issues, but also improve the expressiveness of the language and stuff. And it's a great project. It's super complex, and it's a project that has been created by and for developers. So the documentation, for example, is almost non-existent. So that's not great. But in any case, you will need to analyze some SQL, even if you don't want to implement your own engine. But if you want to do something like, hey, I want to analyze this expression, modify that in order to do something, or to let's say in trying to audit the kind of SQL the SQL sentences you have been executing and things like that. Calcite it's super great. Right? It's a very nice tool to use and super, super powerful.
And I think the other thing too is that as Pinot has matured, it's been leveraging Calcite more and more. Initially, from what I understand, the SQL parser was what we were relying upon mostly, but then especially with V2 engine, the validator and the query optimizer became far more important. And I do want to also point out that we're not using the Calcite JDBC drivers. So Apache Pinot is not using that portion of Calcite, but all the rest of it we're heavily utilizing.
Yeah, and also you say that your background is from NoSQL. Calcite also has some very nice features to deal with NoSQL as well, because you can use the upper layer, which is the parser and the JDBC drivers and stuff. But
Mhm.
under the hood, you have basically you translate these SQL expressions into relational logic, and
Hmm.
then you can do whatever you want there. And in fact, they have some in the open source community. We have some adapters that are able to, for example, translate queries from MongoDB into relational algebra, and then you can do
Right.
whatever you want. And I mean, it's not the main use case, but it's something you can do, and it's some interesting. I mean, there are a lot of interesting things that people can do with Calcite.
Yeah. Yeah. It's, and I think that if anything, our some of our documentation just scratches the surface of what's going on with Calcite in our architecture. So that's one of the things as a product marketing guy I would like to change and see happen is to have far better um, clarity in showing how Calcite works under the hood. Now, is that needed for you to just use Pinot? Absolutely not. But I think that it's probably something that we want to spend more time on in 2024 is showing the fact that you have these really awesome infrastructural components underneath the hood. All right, the next one is Groovy. Now, again, I mentioned there's a lot of open source databases out there that might be using Lua for UDFs. Others are using WebAssembly, but because we're a Java-based database and Groovy is basically Java-compatible syntax, it was a natural language to implement our UDFs in. Um, so you now have basically a lot of choices. You have a lot of built-in scalar functions that you could use for doing certain functions. There are other things that you might want to be using Apache Groovy for UDFs. And in fact, you might also want to consider doing some of these transformations off box using, let's say, Apache Flink upfront. So you really need to think through what your strategy is. There's advantages to Groovy in terms of how it works. But there are also risks to it too. Once you allow people to run UDFs, they can run a lot of UDFs. So you have to be careful about the security of Groovy, and you have to be concerned about the workload it might be producing on your servers. But Groovy, again, another just a rich history here. It's now over 20 years old, getting started by and conceptually in a blog in 2003. And we're not the only database that's using Groovy. I think I saw that SAP is also using it. There's a lot, and of course you can also use Groovy on, let's say, the client side to do some scripting, and then send that through any sort of SQL driver. But we're using it on the server side. And I believe that we use that on minion tasks as well as some server-side tasks. You want to talk more, Gonzalo,
Yeah,
how we can use
we
this?
mostly use Ruby to let customers or users to define their own transformations in the data. And you say one of the things you can do is to, for example, ingest the data originally in Kafka or whatever source you want to use, then use some adapter, some translator like Flink to do some complex transformations and then send the data to Pinot. But sometimes you don't need to use Flink. Sometimes your data in Kafka, for example, is almost the one you want in your table. You want to do some small changes, and in order to do that, you can either use a standard SQL during the ingestion, or you can use if that you want to do something that is we don't have an operation or function that does exactly what you want to do, or you simply feel I mean you feel that it's easier for you to write it in Ruby. You can just write the expression in Ruby, and then we are going to evaluate that whenever we are ingesting new data. So you can enrich your columns or your rows and using that. And and I think that's the main feature, the main reason why we use Groovy in our system. So it's mostly being used in the minions, but also in the servers, depending on the way you are ingesting the data.
Mm-hmm. And by the way, there is an open roadmap GitHub issue on putting access control lists on this so that you wouldn't just have anybody running arbitrary Groovy scripts. So that is in the roadmap to lock those down a little bit better for some security and reliability, as it were. Okay, next one I want to talk about is Netti. And in fact, this is the one project I was really proud. Like I knew about this before coming here because I'd been familiar with how Apache Cassandra had implemented Netti for Java Network I/O. And I had been working for a C++ written database vendor that, of course, was using AIO, right there. And so for folks who are not familiar, the important thing here is that there's a heck of a lot of inter-node communications going on. And if all of that has to be like synchronous IO, if all of it's like locking and blocking and stuff like that, you're really going to hammer a lot of latency and throughput capabilities here. So Netti was implemented to make sure that you can do a lot more fire and forget type of messaging between brokers and servers and the controller and stuff like that. So just about every node in the Pinot cluster is using Netti for asynchronous IO. And so it can boost, particularly under heavy workload, particularly as your QPS climbs, Netti IO's capacity becomes more apparent. And so there are now Netti native transports. There's ePull for Linux. There's KQ for Mac OS. And so you can actually check out this pull request to see, what some of those benefits are. The other thing is that you can run Netti both securely under TLS or unsecure if, for instance, you're just spinning up a cluster and you don't want to pay the TLS hit for just like piping data into a dev cluster or into a cluster you're migrating to. And then, of course, once you're in production, you can apply the TLS to the transactions on it. So Netti is a great, nice way of getting some speed improvement for the developers. It's all kind of transparent. This is all happening in the background. Just in terms of history, it grew out of JBoss, but it split from JBoss in around 2011. So you can learn more about that at netti.io. So it's about a decade, 12 years plus old project at this point, maybe 20 years if you go back to the JBoss roots.
Yeah, and you say we use Netti mostly in our internal communication when
Right.
data is sent from servers to brokers mostly. And because sometimes you have to send a lot of information from one to the other. For example, if you want to execute some distinct count, you need to send all the distinct values from the servers to the brokers in order to compute the final result. So also the normal protocol, I mean, when you communicate with Pinot, either by using the controller or the broker, the information is sent as REST messages, as JSON messages in plain text, and that is not super efficient. But usually you don't need to you are not going. I hope you are not using Pinot to read like a million rows, fetch a million rows from Pinot into your application, because that's not the thing you should be using Pinot to, right? The thing you should do is to try to move your logic to Pinot itself. So we are going to evaluate that faster than you will do in the application layer, right? So usually you don't need to fetch a lot of information. You need to fetch like, I don't know, the top 10 of whatever metric you are using, this kind of thing, right? But sometimes between the servers and the brokers, we need to move a lot of information. And therefore we use a binary protocol that is more efficient than just using REST everywhere. And that is when we mostly use Netti. In the multi-stage query engine, we are also using gRPC because, well, that's the implementation we decided to use. And yeah, it's also asynchronous, but yeah, Netti is still the main framework we use to deal with high efficient network.
Right. So the broker has to marshal a lot of information, and it might be getting communications in from a bunch of different servers on the back end, and it's getting all those results marshaled independently using Netti. And then
Yeah.
basically it's just returning the lightweight result set to you. So you don't have to worry about those internal communications. You're just
Yeah,
getting the rows that
and
are.
by using the asynchronous nature of Netti, we can execute like hundreds of thousands of queries per second without
Yeah.
having actually one thread per query and kind of things that some systems are used to, but it's problematic to have so many threads running at the same time.
Mhm.
So that's something we can avoid with that.
Yeah, so when we talk about user-facing analytics, this is part of that infrastructure that helps allow us to continue to scale, especially under high QPS workloads.
Yeah.
All right, here's another one. This one was new to me. This is the exact opposite of Netti. I had known about Netti before coming here. I had never heard of roaring bitmaps, but it's like, okay, well, let's dig into this here. So it's a compressed bit set or bitmap. It allows you to save a lot of memory, which can be up to 100 times faster by using this roaring bitmaps. It's not doing full run length encoding. It's basically using 216 integer chunks, which allows you to just like dive into certain portions of it, which is why you're getting the speed improvement. You don't have to read the whole thing each time. And it's used in a lot of different Apache Pinot indexes. I have a link here to how it's used in the range indexing as an example if you want to read the docs. And we'll provide a link to this presentation after the webinar wraps so that you can have access to all of these links here. It can also be used for dealing with nulls in a query. And, when you're talking about a lot of data, there's a lot of data sets out there that are very sparse, and there's a lot of nulls, right? So for those, that is also going to help you when dealing with a sparse data set. There is a great blog that I've given a link to from Richard Starlin. He is an Apache Pinot committer, and he talks about how roaring bitmaps is used. It's also, by the way, the same roaring bitmaps is used in ClickHouse, right? So we're not the only people that know these tricks. These are open source implementations, and you'll see a lot of these things will be design patterns from open source project to open source project. But you can learn more here from the code or at the roaringbitmaps.org site. Is there anything you wanted to say about that, Gonzalo?
Yeah, as you said, rolling bitmaps are used everywhere in modern databases, and especially in Pinot, we use them a lot in different places. I think rolling bitmaps are a very interesting structure and a very smart design. And I highly recommend you to read either the documentation or the Richard Starling blog post, because it's a super interesting tool that maybe in some normal, in your normal application, you are not going to need to do these kind of things. But suddenly you find, hey, if you read this blog, you may say, hey, that sounds like something that rolling bitmap is doing. So maybe I can use that and improve the performance of my application by several orders of magnitude just by changing this data structure. So yeah, it's a super cool tool, and it's very, I mean, as I said, most modern databases are using that because it's a nice way to store basically a large set of numbers and in a very efficient way.
Mm-hmm. And I think that's really important when you start talking about using very large data sets, right? So again, if you're saving memory, if you're relieving memory pressure, that's hugely important. Now, it may not be important if your data set's pretty small and you have big chunky servers, but when you're trying to stuff these servers with as much data as possible and you only have so much RAM, if you can save memory, that's definitely going to be saving you your cloud bill every month too. All right, now we're finally going to be leaving Apache Pinot proper, but we wanted to give you guys a little bit of a look under the hood of StarTree Cloud. And so again, this is not part of Apache Pinot, but when we were making Apache Pinot a cloud-based database as a service, we wanted to improve upon open source. And this was a very interesting thing. When you're doing upserts, we're just talking about memory pressure for roaring bitmaps. When you're doing upserts, there is a lot of memory pressure that you can have, keeping these upserts in memory. So instead, what we decided to do was persist these upserts into RocksDB, and then only buffer some in memory. So that relieved a lot of memory pressure for us, but it also meant that upserts could scale much better. And so again, this was something we added. So even though we're running a database as a service, we're still also using open source in the implementation of that database as a service. All right. Is there anything you wanted to mention here, Gonzalo, about this?
Um, I mean, RocksDB is very well known. And there, again,
Yes.
running bitmaps, RocksDB, I guess they are even more well known. RocksDB is even more well known. RocksDB is being used as alternative backend for MySQL. It was used as an alternative backend for MongoDB. It's I mean, it says that it's called RocksDB, but it's not actually a DB itself, like these other systems. It's a library, really. It's a library that you can use to store information
Hmm.
and be able to look for it very fast. And again, if that's something that a lot of people could be using in their normal workday, because it's a way to store information without having to, reinvent the wheel or these kind of things. So I think it's super interesting to look for new usage of RockDB beyond,
Hmm.
hey, yeah, my database is using RockDB under the hood. Yeah, well, maybe you can use it even as a way to share information between your services and stuff. So super cool project. And also very difficult to use. I mean, very difficult to tune. In our case, for example, we found that when we had like super high ingestion rates, we had some issues and we had to tune it a bit. And it's a project that, again, super powerful, but it's not trivial to manage. So that's something that has to be said.
Yeah, and we have a great question here from Thomas. I'm just going to read it aloud. Do you have many customers adopting RocksDB as an I/O storage interface? And I just want to make clear that Apache Pinot has its own storage index, which is not RocksDB based, right? This is not like Roxandra, where they took a Cassandra sort of front end and used a RocksDB backend, nor are we like Rockset that is basing their real-time analytics platform on a RocksDB backend either. So we're just using this for the upsert feature. Okay, but we're not using this as an overall like storage engine underneath Apache Pinot. So again, it's just because upserts are so pressure sensitive, right? You got so many coming on. You could be doing like 1 million operations per second, of which some proportion is going to be upserts, right? And so because you have that huge pressure of ingestion, you want to make sure that if you need to buffer to persistent storage, that relieves the memory pressure on ingestion. Okay,
Yeah.
so that's how we're using it.
Yeah, because in Pinot, when we ingested the information, when we ingested the information is there. You cannot modify the information. I mean, you can do that, but we don't provide an update sentence, right? So usually we ingest your information and create some very large segments, and we store them. And these segments are immutable. In case you want to rewrite your history or your data, you have to destroy that segment and create it again. You can do that in several ways, but at the end of the day, that's what you have to do. So in that sense, RocksDB is not useful for us because RocksDB is designed to be able to modify row by row very fast, but the modification unit is a row, right? So we don't need to use that in Pinot to store the information because our system was specifically crafted trying to fix some problems, right? And these problems don't really need to modify the data. And that's a property we can use to create, for example, StarTree indexes and these kind of things that make the database super fast. But there is a place in the upsert where we actually need to modify the information very fast. And usually, in most of the cases, you're going to be fine storing that in memory. But if you have a very large table with tons of different unique keys, then in that case, RocksDB is great. And in fact, it's a funny thing. RocksDB is used to store information on disk, but we don't actually store information that has to persist. It's something that even if you restart the machine, you can just drop the information that is in your RocksDB file because you don't really care about that. The source of truth is the segment, and the segment is written in our own format. But RocksDB is used just as let's say, as a cache or something like that of the
Yeah,
upserted information.
yeah. So it's kind of like an ingestion time persistent cache, which is a weird thing to say.
Yeah.
All right, so that brings us basically to the overview of what we have today. And of course, this is just scratching the surface. If you really get down into the GitHub issues and you look in the details in the dark corners, you'll find more open source in there. But these are just kind of like the most apparent uses of open source that we have that helps us bring Apache Pinot, faster and further into market. It really helped jumpstart a lot of projects like you've seen with, let's say, Apache Lucene. That was an initial jumpstart, and then we did some native kinds of things on top of that. But we still haven't deprecated Lucene, right? Let's see. Oh, Apache Pinot now has TTL support to address the same issue. There you go. Right. So that's the other thing too, is that what we did for our cloud service, you'll see then the open source project continue to also improve its own feature set over time, right? So things that we're doing for Apache for StarTree Cloud, you'll probably see some form of implementation of these in the open source in due time. So if there's any other questions, certainly let us know. Put them in, we'll give you a couple of minutes to put any questions in there. But otherwise, I just wanted to thank Gonzalo because again, this was a lot of content for me to go through, a lot of things that I was learning. And I'm sure that some of you guys out there are probably familiar with some of these, but others were new to you as well. So if there's any questions you have, we'll take them now. I don't see any coming up. So then if that's the case, then we'll just say thank you so very much. If you'd like to stay in touch with us, certainly join the Apache Pinot Slack community. I tend to, let the open source community be on its own. I'll be more in the StarTree Slack though, if you want to find out anything from me. And of course, there's a Reddit group, r/Apache Pinot, and Yarden, our community manager, is now one of the admins there as well. You can also find us on social media at Apache Pinot on Twitter or StarTree Data. And on behalf of Gonzalo, myself, Yarden, and all the rest of us at StarTree, thank you very much for attending today.
Thank you.